So we continue with this example solving linear systems in three variables, and we have this word problem. It's similar to the previous example, and this one says, Timber Landscaping makes 3 seasonal blends of lawn fertilizer, a spring fertilizer, a summer fertilizer, and a fall fertilizer. Each bag of spring fertilizer contains 5 pounds of nitrogen, 4 pounds of potassium, and 4 pounds of phosphates. Each bag of summer fertilizer contains 4 pounds of nitrogen, 2 pounds of potassium, and 2 pounds of phosphates. And bags of fall fertilizer contain 6 pounds of nitrogen, 1 pound of potassium, and 2 pounds of phosphates. If Timber Landscaping has 416 pounds of nitrogen, 179 pounds of potassium, and 210 pounds of phosphates on hand, determine how many bags of each blend of fertilizer they can make. Now recall that word problems will contain rows and columns, and we'll construct a table to organize the items. And as we look right here, we want to see how many bags of each blend. So this is going to be our value that fluctuates. That's the one that we have to determine. So that's the one that's going to be the variables. And in our table, the variables go across the top and they wind up creating columns. And those variables, the values that are going to fluctuate, are the spring fertilizer, the summer fertilizer, and the fall fertilizer. Now for the rows are instances on how the variables occur. And those instances are nitrogen, potassium, and here we have phosphates over here. Also, the rows will contain the totals, and we have a total of 416 right here, 179 pounds of potassium right here, and 210 for the phosphates right here. So now that we have all this information, we can build our table, and the table should look something like this. So you can see we have our variables across the top here, creating these columns, and then each one of these rows is a linear equation that represents the relationship between the variables and the amount of each item. So now from here, we can go ahead and make our system of linear equations. So we're just going to put down 5x right from here, 5x plus 4y plus 6z, remembering that x represents the spring fertilizer, y represents the summer fertilizer, and z represents the fall. And that's going to equal to 416. Then we have 4x plus 2y plus z, and that's a total of 179. And then finally we have 4x plus 2y plus 2z, and it equals to 210. Then we go ahead and we close off our system here. So this is the system of linear equations that models this scenario here. So now that we have this system, we can write an augmented matrix to represent the system so that we can eventually solve. So the matrix over here, we have 5, 4, 6, and then we put in our vertical line. Now recall, for the vertical line, the values to the left of the vertical line, this is the matrix of coefficients. These are the values that are attached to the variables. And then the values that are going to be to the right over here are going to be our coefficients of constants. Those are going to be our totals. So this one's going to be 416. Then we have 4, 2, 1, and 179. And then 4, 2, and 2, and that comes out to be 210. And now we can close off our matrix. So this is the augmented matrix that now models this scenario. And of course, we're going to use elementary row operations to solve it. And the whole idea is we're going to change each one of these columns into a unit column. And recall that a unit column is where only one of the values is a 1 and the rest are zeros. And when we do that, we want to create a diagonal of 1s right here. So we'll do that. So as we look right here, we have a 1 in our Z column here. So maybe if it was at the bottom here, then I can kind of start my diagonal going this way. So what I'm going to do is we're going to flip-flop these two rows right here. So we're going to take row 2 and we're going to swap it with row 3. That's going to be our first transition. So we'll have 5, 4, 6, our vertical line, 416, and then this is going to be 4, 2, 2, and 210, and then 4, 2, 1, and 179. So you could see how we flip-flopped or changed row 1, I'm sorry, row 2 with row 3. So now we're going to change these other values here into zeros. And it doesn't really matter which row you start with. We're just going to go ahead and we'll start with the second row here. So we'll take row 2 and we'll subtract out 2 times row 3. So 4 times 2 is 8, and 4 minus 8 is negative 4. 2 times 2 is 4, and 2 minus 4, that's negative 2. And 1 times 2 is 2, and 2 minus 2 is 0. And of course, that's the whole idea. Put in our vertical line. So 179 times 2, that's 358. 210 minus 358 is negative 148. Close off the bracket and fill in the rest of the values. 5, 4, 6, 416, 4, 2, 1, and 179. So now we go ahead and we target this value here because we want to get zeros here. So we'll do row 1 and we'll subtract out 6 times row 3. So 4 times 6, that's 24. And 5 minus 24, that's negative 19. 2 times 6 is 12, and 4 minus 12 is negative 8. And then 1 times 6 is 6, and 6 minus 6 is 0. And again, that's the whole idea. Put in our vertical line. 179 times 6 is 1,074. 416 minus 1,074 is negative 658. Close off the bracket and fill in the rest. Negative 4, negative 2, 0, negative 148, 4, 2, 1, and 179. So we've now created a unit column here. So this column is done. So if we want to change this value, if we look closely here, everything is even here, and they all have negatives. So all I'm going to do is we're going to multiply this by negative 1/2. So I'm going to take negative 1/2 and multiply that to row 2. So negative 4 times negative 1/2, that's 2. Negative 2 times negative 1/2, that's 1. And 0 times negative 1/2, that's 0. Bring down our vertical line. Negative 148 times negative 1/2, that's 74. Close off our bracket and bring over the rest of the values. So now I'm going to change this to a 0 and this to a 0. And again, it doesn't matter which one you start with. How about if we start up here with the first row up here? So we'll take row 1 and we'll add 8 times row 2. So 2 times 8 is 16. Negative 19 plus 16, negative 3. 1 times 8 is 8. Negative 8 plus 8, 0. Again, that's what we're targeting. And of course, 0 times 8 is 0. So 0 carries here. Put it in our vertical line. So then 74 times 8 is 592. So negative 658 plus 592, that's a negative 66. Close off our bracket and bring over the rest of the values. 2, 1, 0, 74, and 4, 2, 1, and 179. So now we'll target this value here. So we'll take row 3 and we'll minus 2 times row 2. So 2 times 2 is 4, and 4 minus 4 is 0. 1 times 2 is 2, and 2 minus 2 is 0. And of course 0 is 0. And we bring down our 1, bring down the vertical line. Then we have 74 times 2, that's 148. 179 minus 148, and that's 31. Close off our matrix and bring over the rest of the values. Negative 3, 0, 0, negative 66, 2, 1, 0, and 74. And as you can see, we finished this column also, so we have this one yet to do. And as you can see right here, this is negative 3 and negative 66. So we'll do negative 1/3 times row 1. Negative 1/3 times negative 3, there's 1. That's 0, and then 0. Bring down the vertical line. Negative 66 times negative 1/3, that's 22. Close off our bracket. Bring over the rest of the values. And now we just target this value here. So we'll do row 2 minus 2 times row 1. One times 2 is 2. 2 minus 2 is 0. And then we have 1 and 0, our vertical line. 2 times 22 is 44, and 74 minus 44 is 30. Close off the bracket. Bring over the rest of the values. So as we can see here, if this is our x, this column here, then x is equal to 22, and x represents the bags of spring fertilizer. So that would be x is equal to 22 bags of the spring fertilizer. If this represents y, then y is equal to 30, and y is our summer fertilizer, so y is equal to 30 bags of the summer fertilizer. And then z here, that's equal to 31. And Z is our fall fertilizer, so we should do 31 bags of fall fertilizer. So the solution should be 22 bags of spring fertilizer, 30 bags of summer fertilizer, and 31 bags of fall fertilizer. Now we can go ahead and we can check all this by slugging it back into our system of linear equations. So we'll do that. So we'll do 5 times x, which is 22, plus 4 times y, which is 30, plus 6 times z, which is 31. And this should all equal to 416. 5 times 22 is 110. 4 times 30 is 120. And 6 times 31 is 186. Add them all together, and they do equal to 416. So it satisfies the first equation. Now we'll try the second equation. 4 times 22, that's 4 times x, plus 2 times 30, that's our y, plus 31, that's our z. And this should all equal to 179. 4 times 22 is 88. 2 times 30 is 60. And then we have 31. 88 plus 60 plus 31 does come out to be 179, so it satisfies this equation. Let's try the last one. It'll be 4x, which is 22, plus 2y, which is 30, plus 2z, which is 31. And that should all come out to be 210. 4 times 22 is 88. 2 times 30 is 60. 2 times 31 is 62. Add it all up, and it does come out to be 210. So it satisfies all the equations. So this must be the solution, and it'll be the only solution. So they should produce 22 bags of spring fertilizer, 30 bags of summer fertilizer, and 31 bags of fall fertilizer. And there you go.